Welcome to TrendSpark. Here is the newest SignalSpark. Today's topic is NASA's Roman Space Telescope is about to change how we map the universe and how much data one telescope can create. In 1 month, NASA's next space telescope is expected to generate roughly twice the data Hubble produced in 30 years. Not twice the pictures, twice the data, and it is scheduled to leave Earth in less than 3 weeks.
Wait, if Roman makes 30 years of Hubble data in a month, are we about to discover more universe, or just drown in it?
That is the real story. Roman is not replacing Hubble or Webb. It is changing the scale of the search from extraordinary targets to entire populations. Roman's main mirror is 2.4 meters across, essentially Hubble-sized. The trick is behind it. 18 detectors combine into a 300-megapixel wide-field instrument. One exposure covers a patch of sky slightly larger than the full moon, with a field of view at least 100 times Hubble's. Think of Hubble as a brilliant telephoto lens. Roman is the panoramic mode astronomers have been waiting for. NASA says Hubble would need about 1,000 years to cover what Roman can survey in one. That wide view matters because the universe is not a museum. Stars explode. Galaxies bend background light. Planets cross their suns. Objects brighten, fade, and move. Roman will revisit huge areas, turning deep space from a photograph into something closer to a time-lapse. Its broadest core survey will map more than 5,000 square degrees, about 12% of the sky, in under a year and a half. Hundreds of millions of galaxies will show how matter clumped and how cosmic expansion changed. Roman will not photograph dark energy. It will measure the fingerprints dark energy leaves across cosmic history. The sharpness tells astronomers where galaxies are. Their distorted shapes reveal invisible dark matter. Their distances and changing distribution test competing explanations for the universe's accelerating expansion. One telescope, several independent checks. Then Roman turns toward the crowded center of the Milky Way. For 6 72-day seasons, it will sample a wide field about every 12 minutes. When gravity from a foreground star, or a planet, briefly magnifies a background star, Roman can catch the flash. That is gravitational microlensing. Because microlensing does not need a planet to transit its star, it can find worlds far beyond the neighborhoods most missions have explored. NASA expects Roman to reveal around 100,000 exoplanets through transit and microlensing data, including cold worlds and possible rogue planets drifting without a parent star. Roman also carries a smaller experiment with an outsized future, a coronagraph. It uses masks, prisms, and deformable mirrors to suppress a star's glare so a much fainter planet can appear beside it. The instrument is a technology demonstration, not an Earth twin camera. If it works in space, the techniques could help future observatories directly study smaller, colder planets. Roman's job is to prove that this level of starlight control can survive the real thing: launch vibration, temperature swings, and years far from a repair crew. NASA is targeting August 30th at 7:20 a.m. Eastern, 11:20 Universal Time Coordinated, aboard a SpaceX Falcon Heavy from Kennedy's Launch Complex 39A. The date becomes official only after the flight readiness review. Roman will then travel to Sun-Earth L2, roughly 1.5 million kilometers from Earth. At L2, Roman is designed to send down about 11 terabits per day. Over its 5-year primary mission, NASA estimates a 20-petabyte archive. That is why the Roman Research Nexus already exists, a cloud workspace where scientists can analyze the data without dragging the whole universe onto a laptop. Hubble taught us what individual cosmic masterpieces can look like. Webb peers deeper into selected targets. Roman's superpower is the census, enough galaxies, stars, planets, and repeated observations to test whether a beautiful clue is common or a cosmic accident. And the biggest result may be the one nobody planned for. When astronomy gains this much sky, this much time, and this much public data, rare events stop hiding between the frames. Roman is not just a new telescope. It is a new search engine for the universe.
Roman launches soon. After it opens its eyes, what should we investigate first? Rogue planets, dark energy, or the strangest surprise in the data? And tell us what would make these videos even better. We read the comments.
Subscribe to TrendSpark and keep chasing the signal.